Yes, the experiment name is Amplitude Modulation. For this experiment, Amplitude Modulation Transmitter Kit by Falcon company we are using. With this kit, we are going to use or going to measure the modulation index for under modulation, over modulation as well as for perfect modulation. Now, the connections which have to be done that I am showing. So this is a function generator for the modulating signal. This is the function generator or VCO for carrier signal generator. And this is the balance modulator for AM wave. All the circuitry is here in the above circuit. Okay. So first the modulating signal is here. I am taking from this particular input and I am putting this into the signal in of this balance modulator. Next, the carrier signal is to be taken from VCO and it should be connected to the carrier in of the balanced modulator. Now, here for this connection, we have to keep the switch of function generator SW1 in this position, while for carrier, the VCO switch should be kept on for a 500 kilohertz selection. Now after this, we have to connect it to the ground so that we have to take the output from the balanced modulator from which we will observe the modulated wave, and for that the ground connection is here. For this, the ground connection, we are connecting the CRO probes directly to the ground. That is, these are the ground connections. And for the amplitude modulated wave, we are connecting this particular channel. Now, this channel is channel number 2, okay, which I have here in a CRO. Okay. Now, I will connect the channel number 1 to the modulating signal output, which here they have given for the connections. So, this I am connecting it to the modulating signal. If I see on the CRO, we are observing modulating signal on the first channel while amplitude modulated wave on the second channel. First of all, for this particular kit, some settings are to be needed. For these settings, it is necessary that this VCO knob should be kept on the 500 kilohertz so that the carrier frequency is 500 kilohertz, while the modulating signal frequency is adjusted as 1 kilohertz by this frequency knob, and amplitude of the modulating signal is adjusted by this level knob which is present on the function generator. Similarly, the frequency of the carrier can also be adjusted with this frequency knob on the VCO block. Also, the amplitude of the carrier is to be adjusted by the level knob which is available on the VCO. Secondly, this P7 carrier null knob should be kept fully clockwise for this particular experiment, and this level knob is used for the increasing the level of the amplitude modulated wave so that we can measure the proper signal. Now, coming to the point of the CRO reading. If I go here, the upper signal shows the modulating signal, while the lower signal shows the amplitude modulated wave. Now, I will keep this particular amplitude of the modulating signal to be as a 0.5, or I can say that 1 volt peak to peak. Okay, this signal is kept as a 1 volt peak to peak with the help of a knob which is present at the level on the function generator block. If you observe this, we are having these two signals. I will adjust the ground of these two. Okay, so I am adjusting the grounds of these two signals. So this is, I have adjusted it. Now, coming to the point, how to measure the modulation index. First thing is that before going to the modulation index measurement, it is necessary to measure the amplitude of the carrier. So what I will do, I will take out this connection from the first channel and I will put it to the VCO output, which will show you the carrier output on the screen which is on the first channel. So I will be having this particular frequency. So if I adjust, I will just go through that. Okay, so this is 500 kilohertz frequency that I can adjust or I can see. Okay, the amplitude of this particular carrier is adjusted to be as here 1 volt peak to peak. So I will adjust the level as 1 volt peak to peak. Okay, of the carrier signal, which is EC. Okay, and previously we have measured the amplitude of the modulating signal to be as a 0.5 volt peak to peak. Okay, so I will adjust this. Okay, one minute. Now first channel is having modulating signal while second channel is having AM wave. To calculate the modulation index, we have already kept the carrier wave amplitude to be as 1 volt peak to peak, while the amplitude of the modulating signal is 0.5 volt peak to peak, right? So obviously the modulation index is 0.5, which is EM upon EC, that is amplitude of the modulating signal divided by amplitude of carrier signal. So this is measured by the amplitude of EM divided by EC. So for that we can do the calculation as per our requirement, and we can see that the calculation is to be done properly. Okay, so while calculating, M is equal to EM divided by EC, where EM is 0.25 volt peak to peak and EC is 1 volt peak to peak as we have previously measured. So obviously the modulation index is 0.5. Okay. Now the same modulation index can be achieved by the AM modulated wave. Now when I go for this, the ground is at this position. Okay, so I will measure the V mean at this point and V max at this point. So V mean from this point to the minimum is 0.6, while V max is 1.6. Okay, so here reading is V mean is equal to 0.6 and V max is equal to 1.6 volt. Okay, as the knob is on 0.5, we are not multiplying the factor for this. So now the modulation index is V max minus V mean divided by V max plus V mean. Okay, so for that V max minus V mean is 1 volt, while V max plus V mean is 2.2 volt. So 1 upon 2.2, which will be near about coming to as a 0.45, which is the same modulation index which we have obtained previously with the same reading, that is M is equal to 0.5 and M is equal to 0.45. So this is the first reading. It means that we can measure the modulation index from direct the amplitude of the EM and EC. Similarly, from the AM modulated wave by measuring Vmin and Vmax. Now, we can change the amplitude of the modulating signal by the knob of level on the function generator. Just I will increase it to up to 0.6 peak to peak by adjustment. If I go for 1.2, yes, this is 1.2. So obviously here if I go for this, it will be EM is equal to, here it will be 0.6, as it is peak to peak, it is 0.6, and EC is here 1 volt. So obviously EM divided by EC, which is equal to 0.6. Okay, so this is the modulation index now. Now we can measure the same by using the amplitude modulated wave. If I go for measuring here, this is the ground line, and from ground line I will be getting V minimum to be as a 0.5 and 0.4, and maximum Vmax is 1.8. So V mean as a 0.4 and Vmax to be as a 1.8 volt. So I will be having M is equal to Vmax minus Vmin, which is 1.4, and Vmax plus Vmin, which is 2.2. Okay, so 14 divided by 22, so it will be 0. It will be 0.6, something like that. So it will be near about the M, which is we have obtained with the help of a EM divided by EC. These readings are for under modulation, or I can say that linear modulation. So I will go for perfect modulation. When I am going for perfect modulation, I have to keep the amplitude of the EM equal to EC. So in that case, I will keep it to be as 1 volt completely. Okay, so I will go for increasing this. Yes, if you observe this, yes, it is like this. So now it is 0.8. Okay, the amplitude of the modulating signal is total peak to peak is 1.6. So EM is equal to, now it is equal to 0.8 volt. This is third reading that we are having. Here I am getting perfect modulation. If you observe here the dots, I can adjust this. Yes, if you adjust this, you will understand that here perfect combination is there. If I increase slowly, then it will go above modulation, over modulation. So this is perfect. So here M is equal to 0.8 volt. Now already EC is 1 volt. Okay, so M is equal to, I am getting to be as a 0.8, no problem. Okay, but with the help of a amplitude modulated wave, we will calculate this. Okay, so here I think I have moved this something, ground line. So if I measure this, this is to be as a 0.2 and this is completely 2. Okay, so V mean is equal to 0.2 volt and Vmax is equal to 2. Okay, so Vmax minus V mean divided by Vmax plus V mean. Okay, so this is 2 minus 0.2, 1.8 divided by 2.2, which is 18 divided by 22. I can say that 0.9. Okay, so 0.8 and 0.9. So this is actually showing to be as a perfect modulation, but practically it is coming as a 0.9. No problem, this is a practical condition. So still I will try to make it to be clear one. Okay, so I will but it will go for over modulation. As I go on increasing the amplitude of the modulating signal, it will show you the over modulation. See, this is over modulation in amplitude modulated wave. When the magnitude of or amplitude of modulating signal goes beyond the amplitude of the carrier signal, we are getting the over modulation. Next signal that we are having, this is perfect modulation that we are having, this is perfect modulation, and this is under modulation, or I can say that linear modulation. So in this way we can calculate the modulation index for linear modulation also and perfect modulation also. So this is the way that we can calculate the modulation index. Don't change the carrier wave amplitude, only change the amplitude of the EM, so that we will get the proper modulation index in both the ways. Thank you.